Hey everyone, so today's lesson is on the triangle inequality theorem. This section is super easy, maybe even easier than the last one. And this is the theorem right here. Basically all it says is that in order to make a triangle, the sum of the lengths of any two sides must be greater than the length of the third side. So if you look at this picture here, if I were to add A plus B, it's going to be greater than whatever C is. And then if I were to add B plus C, these two together, it will be greater than A. And then if I were to add A plus C, these two, it would be greater than whatever B is. So that's what the triangle inequality theorem says, that two sides added together must be greater than the third side. So sometimes you're asked a question like these first examples where it says, is it possible to form a triangle with the given side lengths? If not, explain why not. So if you're given three side lengths and asked to determine if they could make a triangle, the easiest way to do it is to just take the two smallest numbers, add them together, and see if it's greater than the third side. Technically, you're supposed to do all three sides, but if the two smallest ones are the sum of the two smallest ones are greater than the third, then the other ones would be too. So this is how you would show your work. Let me show you. So I just, if you're looking at number one, I'm going to take the two smallest ones in the group, which are 3 and 4, and then I would write it like this: 3 plus 4, is it greater than 6? Well, 3 plus 4 is 7, which is greater than 6, so we would say this one is a yes. It would make a triangle. Something like number 3, they're all the same, so it's 8 plus 8. Is 8 plus 8 bigger than 8? Yes, it is, because 16 is bigger than 8, so this would also make a triangle. This one, these are the two smaller ones, so 4 plus 8, is that bigger than 16? Well, 4 plus 8 is 12, which is not greater than 16, so we would say that no, this one would not make a triangle. And just this work is good enough. You don't have to actually explain why not. But as long as you show work and don't just write yes or no, then that's good enough. 6 and 9, if you add those together, that gives you exactly 15. So if you're asking yourself, is 6 plus 9 greater than 15? Well, 15 is not greater than 15. So it's a no. So if the two smallest ones add together to equal the third side, that's also a no. Okay. Also, I just want to point out, in these particular examples, the two smaller ones are listed first in the order. That doesn't always happen, just so you know. I think this is just a coincidence that this happened. So this is 2 plus 4. Is that bigger than 5? Yes, it is. 2 plus 4 is 6, and 6 is bigger than 5. So yes, that one would make a triangle. And then lastly, 1.5 plus 2.5, is that bigger than 3? Well, 1.5 plus 2.5 is 4, which is bigger than 3, so we would say yes, it would make a triangle. Okay, so that's the first type of problem that you have to do. The next one says, find the range for the measures of the third side of a triangle given the measures of two sides. So basically, they're giving you two sides, and you have to find the range of values for a possible third side. Like the third side has to be between what two numbers, or bigger than this number and less than this number, something like that. So usually if we did this in class, I would have you guys come up with the rule. But if you think about it, you have two values. So just like think of numbers that would work. Like we have 1 and 6. Would 5 work? I'm just like throwing this out here. Well, 1 plus 5 is 6. 6 is not bigger than 6, so 5 wouldn't work. How about 6? Would 6 work? Well, 1 plus 6 is 7, which is bigger than 6, so great. So that works. What about like 5.5? Does 5.5 work? So like we usually just kind of throw out a bunch of numbers. If you just want to take a minute and think about it, maybe pause the video, see if you can come up with that on your own. Usually kids can figure it out. But basically, to get your range of values, let me make a note like right here in blue. So X represents the third side. It's always going to be less than some number and greater than some number. That's the notation that we write it in. To get the high end of the range, you just add the two numbers. To get the low end of the range, you subtract them. So for this particular example, we would say that the third side is between, so 6 minus 1 is 5. 6 plus 1 is 7. And so this has to be between 5 and 7. So one might say like, oh, well, the only number that's between 5 and 7 is 6. But think about all those decimals. So like 5.1 technically would work. 5.1 plus 1 is 6.1, and that's bigger than 6. That would make a triangle. It'd be a very like thin triangle, but it would work. Or like 6.9. 6.9 would work, right? 1 plus 6 is 7, and 7 is technically bigger than 6.9, so it would still work. So that would be your answer for the first one. This next one, I always just start off by putting my notation. So if I were to subtract them, 18 minus 12 is 6, and then 18 plus 12 is 30. So for this one, it would have to be greater than 6, but less than 30. So that's what you do for this type. And then lastly, there are some proofs in this section. Not too many of them, just a few. And you don't have to write the statements and the reasons. It's kind of like this, where some reasons are given, some statements are given, kind of like mixed up. So let's take a look at what we have here. So we're given that AE is parallel to CD. So let's mark that. And B is the midpoint of EC. So I put all that in the first step that's given. We're being asked to prove that EB rather, so this one, plus BD, this one, is greater than this one. So we're being asked to prove that two segments that aren't in the same triangle are bigger than the third side of this triangle. So based on the triangle inequality theorem, EB and AB added together would be greater than AE. Remember up here, triangle inequality theorem, that's what we talked about at the beginning, how any two sides are greater than the third side. They have to be in the same triangle. So I'm guessing what happens here, oh yeah, look right here in step 6, we say that EB plus AB is greater than AE, and then we end up doing some substitution, I'm sure. So you'll see, I'll walk you through what's happening. So let's start off. It says EB is equal to BC. EB, BC. How do we know that those two are equal? Well, they told us B is the midpoint. So we're going to say definition of midpoint. Whoops. There we go. Next, it says angle A is congruent to angle D. This one here is congruent to this one here. Let me erase this. I kind of made this messy. So A is congruent to D. What type of angles are those? Those are alternate interior. So it's alternate interior angles theorem. Oh no, what the heck just happened? Okay, here we go. Next it says vertical angles theorem. So we must have named these vertical angles. Remember, we have to use 3 letters when you're naming vertical angles. So I'm going to have angle ABE is congruent to angle DBC. And that would be vertical angles theorem. The next step says that the triangles are congruent. So think about how we have triangles that are congruent. It's either side, 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 side angle, side, stuff like that. So you'll look at the picture to see that we have an angle, and a side in both triangles. So it's going to be angle, angle, side. So here's where this is the new theorem. It says EB, use a different color, EB plus AB is bigger than AE. So those 3 segments are all in the same triangle, and we're saying 2 of them added together is bigger than the third. So that's triangle inequality theorem. Okay, next it says CPCTC. So technically we could really use any of these corresponding parts, but let's kind of be strategic here with which ones we use, right? So if in the end, if in the end we want it to say this, AB plus BD is greater than AE, notice that everything is the same except for this. We end up switching AB to BD. So right now what we could say is that AB is equal to BD. And then we could do some substitution to get our final answer. So right here, we're going to say AB is equal to BD, and that's CPCTC, corresponding parts of congruent triangles are congruent. And now we're going to replace AB with BD, and that's substitution property of equality. We haven't done substitution in a while. Remember, that's when you can just replace like things that are equal for one another. And yeah, that's substitution. So that's the proof. There are a couple very similar to this on the practice. And that's it. So if you have any questions, please let me know. Have a great day.